Alright, this is P2 and we're going to talk about the life cycle of a star. Pretty close to the exam now, but you don't need to panic. Yeah, I'm kidding. You do need to panic big time because the exam is just around the corner, so panic as much as you like and get stuck into the revision. We're starting here with a stellar nursery. It is an area containing lots of clouds and gas, and new stars are forming from the nebula. So the clouds of gas and dust are condensing, and massive amounts of gas and dust condense down to form a star, and the starting point is a protostar. A protostar is the early stages of a star as it starts to heat up and collect material. The gas swirls around in a ball, and more stuff is added as the gravity pulls in more material. And there are protostars in this picture forming inside a nebula. Then, once the material has got enough mass, the temperature and pressures inside the ball of gas are such that it can ignite because it starts nuclear fusion. Nuclear fusion is when hydrogen atoms are combined to form helium, and that fusion reaction releases a huge amount of energy. In addition to hydrogen, we can have deuterium, which is hydrogen with a neutron, or tritium, which is hydrogen with 2 neutrons, and they can combine again to form helium, and as I say, that gives out a massive amount of energy. Now, a star like the Sun will last for perhaps 15 billion years, maybe slightly longer, 15 billion years, and at the end of that time it starts running out of fuel. Most of the helium has been produced from the hydrogen, and some of the helium has been combined into higher elements, and what happens is the star starts expanding. It has much less mass than it did at the beginning, and it expands to form a red giant, and the red giant could be large enough to engulf the whole of the orbits of Mercury and Venus, and possibly even the Earth. We think possibly the Sun won't get quite that big, but a huge star. Then what happens depends on the size of the original star, but the star collapses to one of 3 things. Exhibit A would be it would collapse to form a white dwarf, shown here on the right hand side of the screen. So the whole of the Sun would collapse down to something about the size of the Earth, and that would just be a star that is slowly dying and using up the rest of its energy. A larger star could undergo an explosion called a supernova. Supernova explosion throws off the outer layers of the star, and then the inner parts of the star collapse back down and form something called a neutron star. Now, a neutron star is shown in this diagram, so you can imagine a star 10 times bigger than the Sun collapsing down to something around about the size of Devon. Okay, so it would be incredibly dense, far denser than anything you can imagine. You would not be able to pick up a grain of this material. A teaspoon of this material would weigh as much as a mountain. Okay, so it is incredibly dense material. However, that's not the limit. It could collapse even further to become even more dense, and it's so dense that its gravity is so great that light cannot escape from it, and that is what we call a black hole. So a large star could form a supernova and then collapse to become a black hole. Finally, our white dwarf could become a black dwarf. When it runs out of energy, it will become a dark black invisible star. Now, the universe is 15 billion years old, and no star yet has reached that state in its life cycle, but that's what it could become.